My apologies. I was actually speaking on mute by mistake. A warm welcome to all of you who have joined. This course is on DevOps with AWS. Hi, I'm Kallol. I would be your trainer and mentor for the next couple of months while we learn this course. Now, let me first begin by starting. Let me give you an agenda of what we are going to do today. Initially, we are going to, because I've got a very short time period and I have to teach you guys quite a few things here. So what our today's agenda would be to learn about cloud computing, I'll give you the details about it as we move ahead with the session. And then in this cloud computing, we will understand like why we need that, what it is, the types, the major cloud providers, the life cycle of a cloud computing solution. Then we will majorly focus on cloud computing with AWS because this course uses Amazon Web Services. And then finally, we will have a demo. I will give you a real-time hands-on, like how to use the cloud infrastructure provided by AWS. And what we are going to do is we are going to deploy a live website, which would be globally accessible. And we will see how fast we can do it. And before doing that, these points here that I'm going to discuss, this will give you an overview of how cloud computing has actually changed the IT industry for delivering software products. And what is its importance? Like, why is it so? Why has it become so valuable? Could you guys confirm if you are able to hear me clearly and see my screen? Maybe you can post it on chat.
Yes, Kallol. Yeah, I can hear you. It's clear.
Thank you. Cool. Cool.
Yes,
Okay.
yes.
Let's begin. First of all, let's ask ourselves, why do we need cloud computing? Or I'll just write the word cloud. Why do we need cloud at all? So let's imagine a scenario where there is a business owner. He wants to start up a new business. Now he wants to, he or she is planning to set up. So if you're going to start a business, then definitely there will be a major section of computers that you will need. You're going to use softwares, you're going to have multiple users, and it has to have security. So the business owner is planning to create all the infrastructure that is required. What do I mean by infrastructure? Infrastructure. So this will require, this will entail the servers, the databases, the softwares, and the security, like not only security at the software level, but also physical security. All of this stuff, the business owner is planning to do on-premise. On-premise means in their own space, in their own building. Okay, so now the business owner then takes some advice from a cloud architect or a DevOps engineer, DevOps architect. And then the DevOps architect suggests that instead of doing all of this on premise, you can do each and everything on the cloud. So let us then see, I mean, like obviously then the cloud architect, solution architect has to provide some points as to why deploying your softwares, using your softwares, if you compare it with on-premise versus cloud computing. Like how is it more, why cloud computing would be more valuable? So let's quickly see those points. So let's have two sections here. One is on-premise, and compared to that, if we do it in cloud. So cloud and cloud computing, these words are used synonymously. They more or less mean the same thing in everyday, in day-to-day use. So let's see. What are the points which are always in favor of cloud computing? Yeah. First of all, if you are going to procure your servers, if you are going to procure any equipment, be it the routers, switches, the cabling, you need cooling infrastructure. All of that has to be borne by you. You'll have to buy all those equipments. So there is a higher cost here, a very high cost. Even before you start working, this is going to cost you a lot to procure this equipments. Now, let's say you have the money. Even if you have the money, you have to order all these servers, each and everything you will have to order. You will have to prepare the space where you are going to, the rooms and the space, the floors where you are going to deploy all of this. You have to, there will be a networking cost, because depending on the number of servers, depending on the number of users, you will have to allocate space. They will have to be air conditioned. They will need to be provided with 24/7 electricity supply. So all this is going, and all procuring this equipment is going to take time. But apart from that, also it is going to have a very high cost. But compared to that, you can do this. You can get the exact functionality without investing so much on your capex. This is the capital expenditure. CapEx stands for capital expenditure. Once you have to, this is where you are procuring all the equipment that you need. And once you have procured, then you will have to undergo something called OPEX. That is operational expense. So there is capital expense for procuring all the equipment required, the manpower, and then after, once it is all is installed, then you will have operational expense, where to maintain the equipments and the softwares and the computers and the networking, each and everything, you will need to spend money on personnel. You will need to employ people who will have to maintain all of this. Okay, so if you think about it, this is a prerequisite for starting the business. But you have not even started the business, but you are going to spend such a lot of amount. And okay, then the major drawback here is, once you have invested, let's say you have purchased 25 servers. Maybe you are looking at public, you are going to create a, you sell your product online, you have got an online store, and you cater globally. And then for that, you need 25 servers, so that you can cater to, let's say, 50,000 customers on a daily basis. This is your projected customer base. But what if you do not meet that target? What if once you start the business, instead of 50,000, this is actually 10,000? You have already spent a lot of huge amount of money on your 25 servers. Okay, this cost is not going to go away. The other scenario is, maybe your website has become so popular, your product is so popular, that instead of your projected 50,000 customers, now you are getting 100,000 customers. 25 servers will not be able to handle that. So obviously you need 50 servers now. But then for allocating those additional 25 servers, you will have to go through that entire cycle of procuring, deploying, again adding personnel to manage all of that stuff. So the major problem that we can see here is what we call scalability. There is no scaling opportunity here when you are doing everything on premise. Okay, so there is this high cost involved here. But compared to that, if you're going to do, you will get the exact result. The output will be exact. But if you implement your solution through cloud computing, you are going to pay as much as you go. So this is called pay as you go. You will be paying only for the equipments and resources which you are using. So you can, anytime you want, you can scale up. Suppose today you start with 25 servers, but then your business is booming. You can, at any point, you can keep incrementing them. You can keep increasing them. You can go up to 100 servers, as many servers you want. Okay. And similarly, if you are scaling up, you can also scale down. Instead of as in this example, instead of 50,000 customers, if your daily traffic is 10,000 customers, then you don't need 25 servers. Then you can shut down 15 servers. Okay. And then you can work with 10 servers only. So this scaling down, as soon as you scale down, instead of paying for 25 servers, automatically you will be paying only for 10 servers. This is regarding the scaling. Now see, what are the points that favor cloud computing? You do not require any server space. No space required in your premises. So most of the times businesses rent the space where they do business. So when you are going to rent a particular location, in a particular location in a business district, if you're going to rent some real estate space, you will have to sign contracts. Now, now just imagine if you have to increase from 25 servers to 50 servers, then you need another floor. That is not so easy. So here the space constraint is not at all in picture. The entire thing will be provided by the cloud service provider. So there is no space constraint at all. So you are actually saving money by doing this. Then all the hardware, if you are going to use softwares, then you will need hardwares, and you will need not only the software that you are using, but there would be additional softwares also that you will require. For example, if you want to browse the net on your desktop, if you have you will definitely need a browser. But then to use the browser, you definitely need an operating system like Windows or a Mac or a Linux machine. Only the browser will only work on top of that existing operating system. So even to use your own software, you need additional softwares. So all this thing, if you're doing it on premises, you will have to purchase those licenses. But here, it is the cloud service provider's headache. You don't need to bother about the hardware. You don't need to bother about the software. All this will be included in your pay-as-you-go model. So the major thing is you don't need to worry about maintenance of any of the hardware. Moving on. Let me actually make that table again. So this is on-premise, and this is on cloud. There is now security, that is a major concern. Security, not only in terms of software firewall level, but also you need physical security. You need to have, there would be in any building, there would always be an admin team who take care of the security of the building. Like there are fire hazards. There is supposed to be, people who have access. So they would be using, they would have to be allocated cards, which they can punch in so that they can enter the building. So all this security concern, you will have to take care of if you are using systems on premise. But when you are using all of these systems on cloud, this is not a problem at all that you need to bother about. Okay, so on premise data security is questionable, but when you are getting all of these cloud services from service providers like AWS, or Microsoft or Google or Oracle. You don't need to bother about this at all. Okay. Apart from that, let's say there has been some kind of accident in the building. There was a fire or there was an electrical short circuit. So that will directly lead to some kind of data loss. Okay, if the hardware is lost, or there might have been some kind of hack attack, a DDoS attack. So all of this, there will be a very less chance of data recovery. And for business, data is God. Data is the most important thing. So data recovery is very questionable in case of an on-premise thing. But then when you're working in a cloud infrastructure, you have better data, better security. You don't need to bother about it. Apart from that, this security, you can, on your own, you can configure it. When later on I discuss details about AWS, you will be able to understand, like you can secure your individual server, you can secure the individual network, and on top of that, you will be using something called a virtual private cloud. So there are multiple layers of security here, and they are also configurable. Apart from the basic security that the cloud providers will provide you, you also can configure your own security level. And apart from that, there is also one of the most important thing is something called disaster recovery. Please ignore my ugly handwriting. I hope you can understand. So disaster recovery is one of the primary concerns. If you have been following the news, like just a fortnight ago, there had been a major earthquake in Turkey, in the country of Turkey. So this can severely impact, I mean, like natural calamities or major power outages. In just a month back, northern US and Canada, they suffered such a blistering snowstorm that they were out of power. I mean, like it was an emergency situation for them. So if there is no power, no electronic device will work. So all that falls under disaster. And in today's market, if a company has to be successful, they need to be functional 24/7, 365 days a year. Okay, so there is no point of failure and no scope for failure. Now, if you are all of your equipment, all of your hardware, software, if they are all installed in one building, in one space, in one real estate space, and there is some power outage, severe power outage, you might run for a few hours, maybe 12 hours or 24 hours on diesel generators, but then sooner or later this is going to fail. Okay, so there is a single point of failure if you are using infrastructure, if your entire infrastructure is placed on premise. But later on we will see, compared to that in cloud, we have in AWS, we have got something called availability zones. Which means nothing but your entire infrastructure. So there would be region. In a region, there would be availability zones are in short simply termed as AZ. Okay, you will have multiple availability zones, at least 2. And depending on the region, it can go up to 6. And each of these availability zones are bare minimum of, they are at least 100 kilometers apart. 100 kilometers or roughly 60 miles. Okay, your entire infrastructure, you can balance it, you can load balance it, and you can deploy it in multiple zones. Okay, all of these zones are different. Availability zone 1, availability zone 2, availability zone 3. So in case one of the availability zone fails, your customers will still have access to the web applications through your 2 different availability zones. That is the power of cloud. Moving on. For on-premise, there is a lack of flexibility. You're not flexible. Okay, so flexibility is the issue. Be it in terms of real estate space, be it in terms of manpower required, that flexibility is not there. Scaling up, scaling down, that is not there. Okay, so here it is lacking, but here it is present. Okay, now if you are using multiple computers, you are going to use multiple softwares. It's a regular thing. They all require something called updates. Okay, so even if you check if you're using your Windows system, your Mac system, or your Linux system, most of us probably are using Windows on our computers. They all require updates. So on premises, there are no automatic updates. You will have to manually configure them through policies and permissions, and you need an entire team to be handling this stuff. But in case of cloud, the things that you deploy, you can configure them to always have automatic updates. So the updates can be configured to be automatic. So you don't need to worry about it. Okay. Now, if your entire infrastructure is set up on premises in one building or in limited number of buildings nearby, then the collaboration becomes a hindrance. And we all know that the IT infrastructure actually works on geographically spread out regions. People can be collaborating on the same software from the entire world. Okay, but if your entire thing is deployed on premise, then all of the people, they will need to access that secure network, because there will be a secure network in your on premise, and only people who are physically entering that the place. I mean, like, of course you can have VPN and other solutions, but here that VPN and stuff, that thing has to be again configured, and then again you are going to take the help of cloud. You will understand this in the just give me a few more minutes. I will explain this. Here the comparison is between on-premise and cloud in the context that all the infrastructure is set up on premises. Okay, so if the entire network is isolated and situated in on-premise, yes, you definitely have security, but then everybody will have to either use the system within that network, or they will have to connect their system to the network to work. Okay, so this collaboration thing is a great hindrance for on-premise, but the same collaboration on the cloud, anybody can collaborate from any location worldwide. Okay, so this is a further tick mark in favor of cloud. The next thing is accessing data. Remote data access. Now, this is not going to happen for a infrastructure which is completely built on premise, but remote data access can be easily be done through a cloud infrastructure. So basically, that's how the work from home thing actually works. Because first of all, you will need to access, you will need to have an access. So that's the collaboration part. I mean, like, first access is required. Once you get the access, then you will need data. You will need access to softwares or your own operating systems. Okay. And the major part is, one of the major features here is implementation. How long will it take? I mean, like, you think about a project, like you want to build a website. How long will it take if you think about deploying all of the stuff on premise, right? From servers, racks, routers, switches, whatnot. I mean, like, just ordering in bulk 25 servers from China or from Mexico or Philippines, wherever they are majorly produced. All the equipment that you will need, all that is going to take minimum of 1 month, even if you are a priority customer. First, it will be ordered, then it will be processed, then it will be shipped. International shipping does not happen so fast. Okay, it's definitely going to take 1 month. But compared to that, when you're going to use something like, let's say you use AWS cloud services, you can actually do it within a couple of days. You can create an entire data center through a single AWS account. When I'm saying data center, I'm saying a capability something like this. Okay, if I look at images, this is a typical data center where there are racks and racks of servers. Okay, all of this infrastructure requires space, air conditioning, security, 24/7 power supply. And not only that, the buildings in which these are supposed to be installed, like if you want a 24/7 delivery, then even the buildings need to be like earthquake resistant. Okay, so all of this actually is taken care of by the cloud service providers. In our case, this is going to be Amazon, AWS. That is what we are going to work with. So all of this implementation, you can do it very quickly, like just within 1 day. Like if you have all of your code and everything already prepared, then you can actually get it implemented within 1 day. So if we go through all of this, all the points that are in favor of on-premise versus cloud, just have a look. There are so many points which are actually in favor of cloud computing. Needless to say, businesses are actually, that is the reason why they are converting to the cloud infrastructure model. Okay, so obviously this is the proof why cloud computing is far better than using software or deploying software on premise. Cool. Now, what next? So what is actually cloud computing? I'll give only a one-liner here. You more or less have got an idea, but very simply speaking, cloud computing is nothing but the delivery. Delivery of what? Delivery of on demand. Whenever you require, you are going to demand it and use it. On demand, you are demanding what? Computing service. Or rather services. Computing services. This can include building servers, storage solutions, or like whatever field you are working on. It can be for application servers, it can be for web servers, robotics, Internet of Things, whatever service you need. You are going to demand computing services, but you are going to do it over the internet. It is only possible, cloud computing is only possible over the internet. And how? The most important thing here is on a pay-as-you-go model. So you are going to pay only for the services that you are going to use. You're not going to pay anything less or more. So gradually, as you start using AWS console, you will gradually understand like how it is calculated. If you're using servers, it will be on an hourly basis, depending on the kind of server that you are using. If it is storage service, like elastic block storage, then it will be in terms of what is the data rate of transfer that is happening. That is called IOPS. So there are various, like depending on the infrastructure, depending on the resource that you are using, that will depend. But whatever it is, you are going to pay on a transaction basis. Only if you are using it, only then you will pay. But compared to that, just imagine if you would have purchased on an on-premise model, if you would have purchased 25 servers, if you would have purchased 10 networking devices, even if the business is not using it, you have still spent money on that, which is not recoverable anymore. Okay, so this is the basic definition of cloud computing. So rather than, for example, rather than managing files on a local storage device, which would be prone to security issues, cloud computing simply makes it possible to save all your files and folders, all your stuff over the internet. Now, maybe many of you have not realized it. All of us are already using cloud. Whoever has got a Gmail account, they use Google Drive to store their data. Earlier we were, everybody has got a smartphone and everybody likes to snap images of themselves, of their friends, of their loved ones, wherever they go. Now, earlier, before cloud solutions had come in place, very easily you can pile up your phone hard disk with thousands of images, and then your phone will start getting slow. But as soon as cloud came into the picture, you just snap the picture over the internet, it gets stored in Google Cloud instead of saving it locally on your phone. So if you are open, so this is the example. Almost all of us are actually cloud users. We are already using cloud computing. Okay. Now, are there any questions? I'll just give a brief pause here. Let me drink some water. Before I proceed to the next topic. No problem. Anyways, after the end of the session, I will be anyways opening up the platform for Q&A. So this is majorly about cloud. This brief introduction should be good enough for you to understand cloud. Now, once again, this is just a demo session. All the sessions that we conduct, they are all recorded, and you can learn at your own pace. And it won't be a challenge for you to learn. Now, before I get into further technical details here, let me actually show you what our syllabus is. Okay, so the course would be spread across a period of nearly 2 months. 50+ hours of training will be there, and there will be 28 real-time projects. These are hands-on projects. So this is hands-on lab, and these projects I will show you, they are all tailor-made, keeping in mind what are the current industry standards and what are the most important tools that are used for cloud, for DevOps. And when you complete these 28 real-time projects, this hands-on training that you will do on your own, I will show you the path. I will actually do it on the screen. This will be nearly equivalent of 5 years of experience. Real-time people who actually work in DevOps environments, it will be equivalent to 5 years of experience. Okay, so let's go through what are the things here in this 50 hours of mentorship and 28 real-time projects, which are all job-ready. This is a job-ready course. So what is the syllabus here? So there are this entire course curriculum is divided into 2 parts. One is the major project thing. It is divided into modules. So you have got major and minor projects. So these are the major projects. Like many of who already know a few terms here, you will be you would already know these names like Jenkins, Chef, DevOps, SDLC. So if you are new to this, don't get overwhelmed by the new words here. All of these will be explained in detail as we proceed. So you will have major projects. CI/CD is nothing but continuous integration and continuous deployment. Then there are minor projects, and then there are certain projects. As it is broken down into modules, we will not be doing this chronologically. I mean, like, it is not as if we will first complete module 1 and then we will complete module 2. No, it is not going to be like that. Rather, from day 1, we will be starting with minor projects from module 4. And while trying to implement all of these minor projects, we will be parallelly completing bits and pieces of the other modules of the other projects. Okay, and then finally, once we have sufficient knowledge for starting a major project, then we will do it from start to end. Okay, so for example, like deploying developed changes to production server using Jenkins plugin by manual configuration. So this is a major project. You will need to know a lot of tools and a lot of concepts before you can start that. So obviously we will be starting with minor projects first. And while doing those minor projects, we will be getting to know all of these concepts. Now, I'm not going to discuss the entire syllabus, but only the major points. This will be shared with you, so don't worry. There will be a recorded session that will be shared with you, and also there will be this syllabus that will be shared with you. Please touch base with Emmanuel or our sales team, and they will cater to this need. Don't worry about it. Just kindly focus on what I'm showing now. There will be, now many of you might not have come from development background. So for learning DevOps and the tools that are used in DevOps, it is essential to learn Linux. Okay, so all of that will be taught from scratch. So even if you are completely new to this, you will be taught the basic commands, and then how to write those commands, group them together into a script. First, we will deploy things manually. We will understand tech stacks like Apache Web Server, Apache Tomcat Server, how we can, like deploy our web applications, Java applications on a Tomcat server. All of these words that you are seeing, all of these concepts will be discussed in depth, in detail from beginning. We will be using for Git. Many of you must have already, you might know this, but nevertheless, all of this will be taught from scratch. So we will learn how to merge code, how to restore. I mean, like all of this stuff in detail will be done as the classes move ahead. So we will be learning something called Git. And then one of the build tools is Maven. Okay, so what will be the prerequisite? How can you create build? And then how can you use it in a repository? How are you going to use the dependencies, plugins? All these things will be taught from scratch. Then we will be going through Jenkins. That is one of the configuration and primary configuration and management tools that we use in DevOps. Now, keep in mind, initially, when we go through this process, we will all be doing things manually first. Because first we will learn the basic concept, and then we will deploy all the, be it deployment, be it build, all of those things we will do manually. And then finally, since we are going to be DevOps engineers, all of this has to be automated. Otherwise, it does not make sense. So first concept, then manually doing the things, and then automation. This will be the 3-step procedure for learning. So that is the reason why when you go through the syllabus, please don't think that we are going to do it module by module. No, it will be spread across, but over a period of these 50+ hours of training, you will definitely be undergoing each and every project, be it the minor project or be it the 28 major projects. Okay, right from downloading, installing, configuring, managing, building, everything will be taught to you. Now, here I'm just going through the names of the major tools that we are going to use. So Terraform is also one of the softwares that you're going to learn. And the good part is all of these softwares that have been listed here, they are widely used globally by the DevOps community. Okay, so later on you will realize these are not the only tools in the DevOps industry. There are thousands of DevOps tools, but once you understand the concept, the basic core underlying concept of what the tool does, how it does it, what are the basic principles that are implemented, you will not have any problem switching from one tool to another. For example, if you are using Notepad in Windows, most of you would have definitely used it. If you are suddenly given a Mac computer, it will not be a very big challenge for you to shift from Notepad software to text editor. So it is just something like that. If I give you another analogy, if you know how to drive a small four-wheeler, okay, so if you can drive, let's say Maruti Suzuki Swift Desire, maybe that's one of the most popular cars. If you know how to handle that car, then you will also be able to drive a Tata Safari. Okay, the basic principles, they remain the same. For example, cloud, DevOps, what the tools, what each tool does. So all of those things will be taught at a granular level from scratch. And while teaching those, you will also be doing the hands-on for each and every individual project here. So Terraform is one of the most important provisioning softwares that we are going to use. And the best part is these softwares like Terraform, Ansible, and the rest of the things that we are going to use, they are all free source, open source tools. Okay, and they are highly integrable with the cloud providers like AWS. So it does not. So the thing is, all of these names and all of these words like deployment, Docker, Ansible, these might, like, for people who are completely new, it might sound very challenging, and you might not be so this is the first session. You will not be able to, you will be overwhelmed with the concepts, with the words, with the terminologies. So don't get overwhelmed by it. All the things will be taught from scratch. Our objective is to get you in to develop your thought process, your thinking and understanding to such a high level that you can easily crack the interviews. Because if you know the concepts, then you can logically think and answer the questions. It is not possible to memorize all the interview questions in the world. There can be millions of infinite questions, but the concepts which are asked, from which the questions are asked in the interview, they are limited. You can, having said that, definitely you need to work hard. My 1 hour of training would easily convert to at least 2 hours of your self-practice. Because what I'm going to say, I'm going to do, and then you will have to replicate that in your own system. This course is not meant for just passive viewing. You will have to do the things on your own. You will have to replicate the things. So like Ansible, then there is one of the softwares that we are going to use is Kubernetes. All these softwares are the major ones. And hence, these are going to be used towards the end. By that time, you will have sufficient knowledge enough to actually deploy them. Okay, so in short, this is the brief overview of the tools that are going and the projects list, which are part of our course curriculum. So in short, the key takeaway from this is, in this course curriculum, you will have major projects, which are the entire course is divided into modules, which will have major projects and also minor projects. So this course, since it is being taught from scratch, don't worry about even if you are from a non-IT background, if you follow each and every step that I'm saying, you will still be able to learn and do it yourself and successfully crack the interview for becoming a DevOps engineer. Now, having discussed the curriculum, let me get back to the essentials of cloud computing. So till now, I described what cloud computing is. Now, in short, I will just give you a brief overview. What are the types of cloud computing? And then I will jump into the lab session. So what are the types of cloud computing? This question, before you answer, you will need to see from which perspective are you looking at. Are you looking at how it is deployed or how the service is provided? Okay, so one concept of viewing it is through, one of them is called the deployment model. This question can be answered in two ways. If you are looking at it from the perspective of the deployment model, then cloud is of three types, basically public cloud, hybrid cloud, and private cloud. Okay, I'll not get into much technical jargon here. All of this gradually you will have to have the patience of learning it over a period of 2 months. So either you can have public, hybrid, or private, but I will try to explain it with analogies. Excuse me. Now, compared to that, instead of a deployment model, we can also see it in terms of, in the context of a service model, how the service is being provided. So if we check it in terms of the service model, then cloud is actually of three types: IaaS, PaaS, and SaaS. So IaaS is infrastructure as a service, PaaS is platform as a service, and SaaS is nothing but software as a service. Okay, so let me explain the deployment model. If you're looking at it in terms of deployment of model, let me explain that first. Okay, so here we saw that we have got three kinds of cloud: public, private, and then finally hybrid. Okay, so let me give you an analogy. This will be easy for you to understand what I actually mean. Let's say you want to travel from one city, let's say from Bombay to Pune. You want to travel. What are the options? You can go by bus. That is a public service that is accessible to everyone. Or you can go by car, your own car. Now that is only owned by you. Hence it is private. The bus is public. Or you can, let's say you rent a Uber for long distance travel. So it's basically a taxi service. This is a hybrid model. You get all the comforts of the traveling in your own private car, but you don't own the car. This is nothing but the hybrid cloud model. Okay, you can just think of it like this. So in public cloud, the entire infrastructure is made available to the general public over the internet and is owned by the cloud provider, like AWS, Azure, IBM's Blue Cloud, or Sun Cloud. Okay, so that is the concept for a public cloud. Compared to that, when we talk about private cloud, the cloud infrastructure here is exclusively operated by the single organization. It can be managed by the organization or by a third party which they have hired. And they may exist on premise or off premise. The entire cloud infrastructure may be within the organization's building, or it can be on a separate location, which the third party or from whoever the vendor is providing that service to, they own. Okay, or maybe they are renting it. So in this case also, AWS has got solutions for private cloud. And apart from AWS, there is also, you must have also heard about VMware. So that is the concept for private cloud. Compared to that, finally, when we come to hybrid cloud, this will consist of the functionalities, just like the taxi, Uber taxi. It will have the functionalities of both public cloud and also private cloud. So, for example, like government agencies, okay, they will opt for private cloud where sensitive information is involved. Okay, but then, so for example, in India, like we all have our social security card called Aadhaar card. Okay, so the servers on which all the Aadhaar software is maintained by Government of India, that is definitely going to be a public private cloud. That is where all the sensitive information is stored. But then ordinary citizens should have access to their own to the services which are linked with Aadhaar card. They might need to see or update their social security card details, maybe change of address, maybe change of mobile phone. So then that part also needs to be put on, some part of it needs to be put on the public cloud, so that the data sets can be shared with the general public for usage, or even other government departments or other or whoever is going to use it. So that is the, in very simple terms, it is way more deeper than this, but at a very simple high level, you can take it like this. So in terms of deployment, we have got these three kinds of cloud: public, private, and hybrid. Now let me try to explain the service model concept. Okay, in the service model concept, what did we have? If you can recall, we had IaaS, PaaS, and SaaS. Okay, so what does this mean? This is infrastructure as a service, this is platform as a service, and this is software as a service. Let me try to give you some example. Let's start with infrastructure as a service. So let's say a business needs a virtual machine. Okay, they are not going to buy any computer or any server. They are just going to I mean, like the entire server will have to be provided by the cloud provider. So for example, AWS EC2, we use this quite frequently in Amazon Web Services, something called EC2. You can build a server. So this kind of service is IaaS, where the entire infrastructure is being provided. Now compared to that, let's say, so what will IaaS majorly include? It will provide you the basic computing infrastructure. The services will be available on, once again, on pay for what you use. For example, this EC2 instance that you are going to use, this is a kind of server that you are going to create on cloud within the AWS console. You will be charged only for the number of hours this EC2 instance or the computer is in a working state. If you shut it down, if you stop the EC2 instance, leave it for 1 year, you are not going to get charged. You're not going to get billed for that. Okay. So majorly IaaS is used by IT administrators. This is in very short what IaaS means. But compared to that, let us talk about PaaS now, or platform as a required service. So for example, if your company requires only a platform for building software, so you want to build software products, but you only require the platform. That is when you will be choosing platform as a service. Okay. So for example, you can create cloud platforms, runtime environments for developing and testing and managing applications. Platform as a service allows software developers to deploy applications without requiring all the related operating system, networking, and other infrastructure. So PaaS is mainly used by, this kind of service is mainly used by software developers. But compared to that, most of us in daily life, we use something called SaaS or SaaS. If the business simply does not want to maintain any IT equipment at all, then you are directly going to go for software as a service. The entire software will be provided by the cloud provider, and you are simply going to use it. Okay. For example, in SaaS model, the cloud providers will be hosting and managing the entire software application, and you will only be billed for whatever you are using. So for example, if you are using Office 365, if you are using Gmail, if you are using Google Drive, Google Sheet, PowerPoint, Word, all of this you are using in the cloud model, not on the local desktop install model. So all of this can be considered as SaaS. SaaS. The entire software, you just need to log in. That's it. And monthly, I mean, like obviously they come with free packages, but then all the Google collection of softwares, I mean, like Office 365 is one very good example. Okay. The Office 365 and all the Google apps that you use, they are all working under the SaaS model. Neither are you maintaining it, nor are you managing any software hardware. You're doing nothing. You're just using it as a customer. And as much as you use, that will be the charge. So this is the basic idea about IaaS, PaaS, and SaaS. So now, if I move forward with it, I mean, like this is going to become more detailed. So I've already given a 1-hour lecture now, and I've tried your patience enough. So now let us actually do something practical. Okay, so let me give you an idea what kind of lab experiment we are going to do. So our idea here is I don't have any system. I'm not going to buy any server or anything, but I need to deploy very quickly a website. Okay, so this is nothing but a web application in software terms. That is called web app. So I'm going to deploy a website, and I'm going to do that globally. Once I do that, I will share the link with you, and everybody will be able to open it. Okay, and for that, I'm going to use the AWS platform here. I'm going to use Amazon Web Services. In that, I'm going to use, I will not be able to explain each and everything in this session, but this is just a showcase here to show you like how, like all the points I discussed about the importance of cloud service and why it is so widely popular and used by developers and DevOps community. You will understand that. 2 of the services I'm going to use, actually rather 3. I'm in AWS, I'm going to use S3, that is a storage solution, and I'm going to use EC2. This is for building the computer, and then I will need to also authenticate myself. Okay, to have an authenticated interaction. For that, I'm going to use one of the services called IAM in AWS. That is nothing but identity and access management. So don't worry about the new words and terms here. Rather focus on what I'm trying to do. I'm simply trying to deploy a website globally within very less time, as less time as possible. Okay, so let's go ahead with that. Let me prepare my system here first. So first of all, the most important thing that you will have to do is for all of this, you will definitely need a AWS account. So I already have a AWS account. For people who are new, later on, you will learn like how to get it done. Maybe I'll discuss it in the next class. It's not that difficult. So I will sign in. Now I have got a multiple level of security implemented. So without this code, nobody can actually access my system. This code is on a different virtual device. In this case, it is my cell phone where I'm using a a tool called Microsoft Authenticator. So it will be generating a code which will only be valid for 30 seconds. And it will keep changing every time I log in. So this is my Amazon Web Service console. If you look at the services here, any kind of application you want to build, augmented reality, virtual reality, blockchain, compute, web application, database, front end, web, mobile, game development, Internet of Things, machine learning, anything you want to build, you can build here. You can create your entire data center using this single account. Okay, robotics, whatever you can think of. AWS, that is the reason why AWS is so highly popular. So out of all of these services, one of the service, what are the services that we are talking about? We are going to deal with S3, EC2, and IAM. Let's go ahead. So I don't know, there are hundreds of services here. If I get confused, I won't worry. I'll just search here and type in S3. So here I get the S3 service. So this is a kind of storage that I'm defining. This storage is going to, I mean, like the idea here is that you create buckets where you will be uploading files and folders. Okay, so you can store and retrieve any amount of data from this S3 bucket. So first we are creating the storage service. So how do we do that? We create a bucket. Let's click on that. Now I need to give it a name. Now this name has to be unique in the entire world. Okay. So I just can't use very ordinarily used terms. Like if I use test bucket, it won't work. Probably it will give an error when I scroll down and finally click on create bucket. Let's see. I'm just putting in test bucket, by the way. So then I will have to choose a region. Like which region is this? So basically I'm choosing the data center cluster here. So usually just think about it. Now Amazon, let me give you an idea. These are all the regions: US East, US in Virginia, Ohio, US West, in California, Oregon, in Asia Pacific, Mumbai, Osaka. So all of these data center clusters are located for of AWS globally. So AWS got a global outreach. Okay, so then just think about it. It is very common sense now. If my client, customer, he or she is saying that they want to develop their web app in India, their customer base is in India, then I will definitely choose the Asia Pacific Mumbai region. Why? Then the data transfer will happen very quickly. So let me go ahead and choose Asia Pacific Mumbai. So that is the reason of the logic of choosing this region. Wherever your customers are placed nearby, that is the place where you should choose your region. Done. Now there are a few settings. I mean, like for that you will have to understand S3, but here I am just showcasing how to do it without getting into major discussion here. So there is versioning, there is tag, and then encryption. I'll just the bucket key. Let me disable this, and I will just simply create a bucket after choosing the region. So see, test bucket did not allow me because this name is already taken by somebody. Let me use with the date. Probably nobody is using it. And then click on create bucket. So yeah, I have to acknowledge. I'm making it very simple here with very simple restrictions because I'm going to make this public for getting the access to the website. So let me create the bucket. Once I create the bucket, see this test bucket has come up. Okay, the bucket is created. This is the bucket which I created. This is the storage space. Right now, once I have done that, this is ready to use. It is present in the Asia Pacific Mumbai region. I will click on this bucket. And then I need to upload the code file into this. Right? This is the code that will, which the developers will write for deploying the website. One simple thing I'm telling you guys, if you have come from a non-programming or non-development background, don't worry about it. We are going to become DevOps engineers using AWS cloud platform. We will do coding, but that coding is not for development work. That is part of the development team. That job belongs to the development team. The coding that we will learn from scratch to write scripts would be for automating our system, for building applications, for deploying applications. Okay, so our coding is very different from them, and we will learn everything from scratch. Here, we are not responsible for building the web applications as DevOps engineers. We are responsible for deployment, maintenance, build, automation. These are our work areas. Okay. Tomorrow I will discuss about DevOps and what is expected out of the DevOps role of a DevOps engineer, from a DevOps engineer. Okay. So here now I need to upload the code file. So what I'm going to do, I already have the code with me. I'll just add a single HTML file. That will be more than enough for us to work. So one HTML file I will just upload. It just named 1.html. Later on, I will have to rename it. And so it has given me a destination. Fine, I have uploaded it. But then let us check the permission. This bucket has the owner enforced. Fine, properties, storage class. Yes, all of this looks good. So let me add a tag. I'm just naming it code storage because it's an index. It's actually a HTML file. By this, I will be able to filter it out later on. Although I'm just doing it for now, I will be deleting it once this is done. Okay. So all of this should be good. Let me do a final check. Yeah. So the file has been uploaded successfully. Let's close this. So if I choose this file, I can, so under my bucket, test bucket with this date, I have got a file called 1.html. Cool. Done. So is there any action I need to take care of? Here, copy, move. No, all this is good. Fine. Now, if I try to copy the URL here, and let me see what I get. So this is the link for opening 1.html. Will it work? Let's see. So I'm getting some kind of access denied error message. Okay, so there is a lot of configuration that I still need to do, but there is something here which is working in the background. So let's figure this out. We are not going to use this link. Now we have stored our data. We have the data I need, the data repository I have created where all the code files will be stored. So this is more of a, this S3 bucket is nothing but a code repository where the code is kept. Okay. But then I now need a server to make it work. So what should I do? My next step is going to be creating a EC2 instance or building the computer to run this code. Okay, so for that, you will come to your something called EC2. Okay, you can come to this page just by I search for S3. You can search for EC2 and this will come. So this is for creating virtual servers in the cloud. So here AWS is in the deployment model. If you think perspective, AWS is actually working as IaaS. It is providing us infrastructure as a service now, because it is allowing me to build a complete computer from scratch. Let's see. So this is my test.
Hi, Kallol.
Yes.
This is Kiran speaking. Kallol, is this training for 1 hour or 1.5 hours? Because I've got a DSU starting in next 2-3 minutes. I was expecting it to
No
be
problem.
finished in 1 hour.
No problem. If you're not able to continue with the session, we will post the recorded video. You can carry on from there for understanding it.
No, but what I'm trying to understand is like,
It
is
will
it
take
regular
another
2
20
hours?
minutes. It will take
20
another
minutes.
20 minutes. Yes.
Okay, yeah, that's fine, Kallol. Thanks. Thanks.
So let's name it as test server, and we will install the operating system. In this case, we are going to deal with Red Hat Linux. And then we will use one of the freely available T2 micro. All of these details you will learn later on. But right now, my objective is what? Deploy the website globally. So these are the basic steps you can use. So now for authentication, you are going to let us create a key pair. Actually, I forgot to take the name of it. Let me copy the same name, and I will create for authentication. I will create a key with the same name and download it as a .ppk file with RSA encryption. The concepts regarding this, we will have to discuss later on once you guys enroll. So my network settings are looking good here. There are these 3 traffics I have to allow. SSH for connecting to the server, and for web browsing, I will need to allow HTTPS and HTTP traffic. So basically, I'm opening up 3 ports here. Port 22 for SSH, port number 443, port number 80 for HTTP. Okay, these 3 are good enough for us to deploy the server and work and configure with it. Now, moving on. What is the next thing we have to do? The next thing is we have to define the storage space. So in this, on the server, like every computer has got processor, every computer has got like Intel i5. It will have a RAM like 4 GB or 8 GB. And then it will have a hard disk. So hard disk size. So this is the storage hard disk size. This is 10 GB here. And then this is the firewall actually. What in AWS terms, this is called security group. So this is a kind of firewall. So here we are restricting access. What can enter and what can go out of the system. And then there is authentication. So SSH is a different kind of authentication. It is called secure shell. Just like you have your user ID and password to log into your system. So similarly, this is for authenticated login, but it has a completely different system. The purpose is the same. But then the instance type that we have chosen, T2 micro, this actually chooses the CPU and the RAM and also the networking, how strong the networking will be. So this basically defines our virtual server hardware that is required. The chipset, which contains the processor and the RAM and the networking card, that is your instance type. Then your operating system, Red Hat Linux. The network settings are your firewall settings, what you are going to allow. And then finally the storage. You can increase or decrease it as much as you want. But then I'm in the free tier. This I will discuss later on tomorrow. We get up to 30 gigabytes free. So right now I'm using only 10. Let me click on launch instance. It will take a couple of minutes. You have got a launch log here. All the steps have succeeded. So let me go back to the instances. So now in my instances, there are quite a lot of, one is in a stop state. In this account right now, I have got this test server. This is the one that I will be using. Okay, so right now its state is in a pending state. So we will, so it has just become running now. The moment it became running, if I click on this link and open it in a new window, this test server is the name that I gave. But in the background, Amazon will always provide it with a hexadecimal ID to identify it uniquely from among the millions of other EC2 instances being created by hundreds and thousands of other AWS users like me. Okay, so this is going to be a unique ID. It's written in a hexadecimal format. Just like we use decimal system to count money, wherever there are very large numbers involved, you use hexadecimal. It's a 16-digit numeric system. Just like the decimal system that we use is 0 to 9, 10 digits. But here it is going to be 0 to 9, 10 digits, and A, B, C, D, E, F, 6 further characters. Okay. So all of that we will learn not in depth, but at a preliminary level for good enough for us to work with during the networking classes. So now if I see, I have got a public IP address and also a private IP address. Right now I'm interested in the public IP address. If I copy this and if I go to a browser and I paste it, it will not yield any result because nothing is installed on this. In our test3 bucket, we have the file where the coding is written. But then, just like if you want to browse the internet on your desktop, you definitely need a browser like Google Chrome or Firefox. Okay. And then the code, whatever is there, it will run in that. The HTML file will be run on the browser. In this system now, we are going to install that. But first, for that, we first need to connect to it. We will connect using the EC2 instance. And I'm going to use a software called PuTTY. This is what PuTTY looks like. So to log in, you will need something like a format. What is the format? Your username at the host name. So username, whenever you create any new EC2 instance, by default, AWS provides you with the username EC2-user. But your host name will always be a different IP, public IP address. Now, this is the ID using which I will connect. So as I said earlier, this is what you are seeing here is called SSH authentication. This is secure shell and it only works on port 22. Okay. This is the ID path, the entire hostname, username at hostname, where I'm going to connect. But then what is the security key for it? For that, I will need to get into SSH authentication and click on credentials. And then from there, if you remember earlier, I just downloaded this test server file. So I need to use this private key file. That is how Amazon will realize that I am securely, I am the correct person who is trying to log into this server. And when I do that, I will just click on open now. You will get a screen like this. For the first time, you will have to accept it and then see what is happening. You are logged in using EC2 user and using the public key test server. When I uploaded the private key, here it recognized it, it matched it with the public key. So the concept of key is something we will keep for a later date. There is a public and private concept here. Let me change the setting here so that it is easily readable for you. Let us make it Lucida console and use 18 font. So no bold, let it be regular. Okay, apply. Good, good enough. Our computer is now up and running. Now, people who have been using Windows, it might look very awkward and different to you, but you have to keep in mind, we are not going to use any graphical user interface. As DevOps engineers, we are mainly going to use this black screen with command line interface. Whatever you are doing will all be through commands. We will learn all those commands. So right now, what you are looking at is a computer. This computer is not my local desktop. This is a remote desktop. This is placed somewhere in Mumbai and I am speaking to you from Hyderabad. So it is hundreds of miles away from my home on cloud with an operating system called Red Hat Linux. So Red Hat Linux is installed here. Okay. So that's why we are getting red.ht. So it is Red Hat. So the operating system we are working on is Red Hat. But now we are trying to, just like we are trying to deploy a website. So just like for opening a website, you need a browser like Chrome or Firefox. Similarly, in the Linux mode, before you can start working or deploying any software, okay, the first thing that you should do here is you should definitely go ahead. Let us install the software first. Now, actually, you should update your entire operating system first. So for that, let me switch user to root. Later on, you will understand like root user, regular user, system user. All this will be taught in detail in the Linux classes. Okay, so I'm going to use a command called DNF. This is for installing, uninstalling software. So whatever you have been using through mouse click events, like downloading a file, clicking on next, running it, installing it. Instead of that, we have to do this completely by commands. So DNF is the main command, and then it has got a parameter. I want DNF to actually install a particular software. So actually, I'm not going to install right now. Let me update the entire operating system. So for that, there is a different command. It is called update. Okay, and so let's just put DNF update. So now it will check what are the things it can update. From where is it checking? Red Hat has got its own repository from where it will provide the updates. Okay, so it is checking all the repository. It has checked these 3 repositories here, and what are the softwares that can be installed or updated actually. Okay, all of these softwares can be updated. So let us go ahead and do that. At the end, it is asking me, it is showing me that it is going to take up 422 megabits of storage space. We already have a system which is 10 GB, 10 gigabytes storage. So yes, I'm going to click on yes. It's a fresh system. So I have got enough space to get all of this installed. Now, this is going to take a couple of minutes. Let it work in the background, because this is something that we need to work before we can proceed with our deployment of the website. So during this time, if anybody has any questions, please feel free to ask, because this is going to take a couple of minutes. Any doubts, and it has to be contextual. Like the context here is whatever we have learned from the beginning today. Please feel free to ask, be it on chat or be it on, like you can unmute yourself and ask me.
Hi, I just have one question.
Go ahead, please.
Yeah, you just, rebooted the entire OS. Is that really necessary every time we deploy the application?
Okay, you said I rebooted the entire OS?
You said something with the OS. What did you do? Probably I got.
No, this is the first time I have logged into the OS. When you say OS, you mean this black screen, right? The remote screen, right? No,
yeah.
I have not yet. I have done no reboot.
Okay, what are we doing? What are we updating here?
What are we updating? Okay, so what kind of computer do you use? Like a Windows or a Mac?
I use, I think it's Windows.
Okay.
It's ThinkPad, yeah.
Okay, so ThinkPad, it is the IBM, I think Lenovo ThinkPad. So it is going to be Windows. By default, if you have purchased it, then by default, it should be Windows. So Windows, if you see, Windows will always take updates, right?
Yeah.
Right? Windows has its own updates, right?
Yes.
So once the operating system is installed, the by default, it will not be updated. So that is what I'm doing now. I checked, and all these updates, before moving forward, you need to update your system. That is what is happening. I have not done any reboot. This is the first time. After first time installation, it is updating the entire operating system. That is one of the preliminary steps that we should do before working on a server. Make sense?
Yeah. So that does mean whenever you are deploying the application, you don't have to do this process every single time, because you might deploy the multiple applications in the day-to-day. So
exactly. Now, this is actually a bit vague, your statement. It will depend on exactly what we are trying to achieve. You might have different servers for different kinds of applications. So basically, you will have web applications, web servers for web applications, application servers for things like Tomcat, Apache, and stuff like that. So later on, we will learned something called a 3-tier architecture, how we break down the software modules on a presentation layer, on a application layer, and on a database layer. So based on those layers, you will need different kinds of servers. So you will basically have web servers, application servers, and database servers. So depending on the server type, your application will be, or whatever you are installing, you will install on that. So right now I'm trying to deploy a website. So that's the reason I will be installing applications for, I'm going to make it as a web server. Okay. Now the restart thing that you said, when I will be using something called Apache HTTP server. So right now, see this public IP, this is what I'm going to work with. It is not yielding any result, but it will shortly. So I'm going to use something called Apache HTTP server. Apache is the main company. It has got many softwares. But right now, I'm only talking about Apache HTTP server project, this software. Okay. This I'm going to install in my remote system.
So that leads to my second question. So now we've done that, and if we are deploying the same kind of Tomcat Apache server web application,
not Tomcat. Let me correct you, my dear. Not in Tomcat is for application server. This is HTTP server.
Okay. All right. Sorry.
Please use Apache HTTP server or web server.
All right. So if I'm going to deploy the same type of web application again, do I have to do this process again?
No.
Okay.
Now
so
there are various ways. See. Till now, I have only updated my operating system. What is my operating system? It is Red Hat Linux version 9. While where is that thing? So if I actually click on launch instance here, now you will see AWS actually provides you with a long list of available softwares. I could have installed Windows, I could have installed Ubuntu, a Mac, Red Hat. So Red Hat is one of the most popular and widely used Linux systems. We are majorly going to work with Linux. So as part of this workshop here, I'm giving you training on Linux here. So this is Red Hat Linux version 9 that you have installed. So only the operating system has been installed till now. But just like I said, on your Windows ThinkPad computer, if you want to browse the internet, you need a browser software, right? Something like Google Chrome, Microsoft Edge, or Firefox, or Opera, okay, or Safari. So now to make this thing work, so that is why when we are trying to hit this website, nothing is happening. Let us make it work. Why? Because the software is not installed. So what is, let me clear the screen so you will understand now step by step. It's a very good question. So just see what happens now. Now I'm going to the command. So don't get into the details of the command. I can't teach and impart my knowledge in one single day. This is something which will happen over a period of 2 months. Okay. So right now I'm I'm giving you a one-liner to everybody, like what this command is doing. So I'm going to install the required software so that my web server can render the web pages. Okay. So for that, what we were calling this as Apache HTTP server project, this same software in the Linux world is called HTTPD. That is the name of the software. And after that, I will put a -y so that it installs it without asking me. I'm giving the permission in the beginning, -y. Okay, so again, it is checking the repository. So Red Hat Enterprise Linux, they have got their own databases from where they can, where this HTTPD software is available. And then this software has got installed. Okay, while installing HTTPD, it required other dependent software. These are called dependencies. Let us not get into the details. That is for a future session. So these also got installed. I did not need to worry. I mean, like that is the power of this DNF command. Actually, it might seem tedious to keep typing on your on a black screen, but actually these commands in Linux are way more powerful with what you do with mouse click events in your Windows system. Okay, so now I have successfully installed the HTTPD software. So the software required is deployed. Let me refresh this page. Is it working?
No.
No, it is not. It will go round and round. I need that next important step that I need to do is, let me clear the screen. Clear is the command. I need to check if this service is running or not. Okay, so for that, I will use a command called systemctl. And then status. Status of what? Status of the HTTPD.
Kallol, one question, please.
Yes.
So once you install the application software in S3 bucket, then you created an EC2
No,
instance.
I did not. No, wrong sentence. I did not install any application software in S3 bucket.
Sorry, you stored it, right? You stored it there.
I stored the code file. The code.
Okay.
There is a code written in this one.html file. Okay.
Correct. Okay.
Okay. So let me actually try to open it. So there is some code written here like this. This is not our job. This will be provided by
developer's job. Yeah.
Okay. So don't worry about this. So that file, that is a file, right? That I have stored. This is my code repository. I will pull this file, but to pull this file, I need to do it through a system, right?
Correct. So that's the reason you created an EC2 instance.
Okay.
Okay.
But then I'm seeing this EC2 instance, and not only do I have to create a EC2 instance, I also need to provide the required softwares in it. Otherwise, it will not.
Operating system. Yeah.
No, operating system is there. This is operating system. Don't expect any mouse click event. Don't expect any desktop screen. This is the this black screen is your Linux computer.
Okay. Yeah, got you.
All DevOps engineers work in this kind of screen. So it won't be like the laptop screen, my computer screen that you are seeing here. Okay, this is Windows. Here I can move mouse, I can click on buttons, I can do stuff whatever I want. This is called graphical user interface. But this is command line interface. The only thing that you can do here will be only through commands. So take that out of your mind completely. This is a new world. Okay. So now, let me get back to what I was doing. The HTTPD service is installed, but as we can see, its status is inactive. It is dead. No wonder this is not opening. This page is not opening. Something should come up. So I need to start this service. This is how you do troubleshooting. So again, the same command I will use. See the same command I am using again, but with a different parameter. Gradually, as you start learning Linux, you will understand that Linux commands are way more powerful than normal graphical user interface commands. So using systemctl, now earlier I checked the status, so I'm going to start a service. Which service? Again, HTTPD. The only thing here is don't make spelling errors. It will not correct you by default. So something happened. It went to the next line. Okay. Usually 99% of times in Linux, if something has been done correctly, it will just move on to the next line. Okay. So, but how do I know if it is working properly or not? I will again use systemctl status. I have started the service. So I will check. Earlier it was inactive and dead. Now we can see it is active and running. Okay. So if I quit, clear. If I go back to my page again, see, I did not even need to refresh it. Automatically, I've got the Red Hat Linux Enterprise test page. Make sense?
Yeah, it does.
Okay. But the thing is, you asked earlier, I'm sorry, I don't know your names. So it is very difficult for me to also recognize if many people speak. So let us just communicate with pronouns. That's fine. Later on, we will get to know each other and then I will remember your name. I apologize for that. But you had asked a question like, do I have to do this again and again? Now, the thing is, if my EC2 instance is running here now, it is in a running state. If I actually stop this instance now, this is equal to shutting down your computer. Like if I click on power and if I click on shutdown, my computer will shut down. Similarly, you can shut down your remote system, because as long as it is running. So earlier I said pay-as-you-go model. This is that pay-as-you-go model. As long as it is running, AWS will be charging you. So if you stop the instance, then you will not get charged. It is as simple as that. So let's say you created 100 servers and 100 servers run for 2 hours. So that is a charge of 200 hours. But then your business is saying we don't need so many servers. Okay, let us reduce it. So you reduce 80 servers. Now only 20 servers are running. So you will be charged only for 20 servers. Just imagine, would you have been able to do that on an on-premise model? No. Once you had procured 100 servers, even if you shut down 80 servers, still that amount that was spent on it, 100 servers, that is spent, that is gone. Okay, so this is called scalability. Scaling up, scaling down as per the requirement. And this can be automated also. The moment your hits, customer website hits start increasing, we can write code where it will automatically scale up and create new EC2 instances. Okay, so let's go ahead. Our test page, but is this our test page? We are looking for no. Our actual file is placed in the S3 bucket. This is our code repository. Okay, so what do we do next? To answer your question, where I mean, like if I stop the instance and then I start it again, this website will not work. Why? Because right now, as we saw, the HTTP service is running. But as soon as you shut down the computer, this service will go dead. Okay, now so that it works automatically, there is an additional command you need to type in, that is again using systemctl. See, this is the power of Linux. Using one single command, but changing the parameter, I'm doing multiple tasks. I'm checking the status, I'm starting the service, I'm stopping the service. I am now going to type in a word called enable. Enable HTTPD. This means what? It did something here, right? It gave you a message. So what it did was, even if I shut down my EC2 instance and then again I start it up, automatically it will also start the HTTPD service. So as soon as my EC2 is running, this page will be rendered. Make sense? You were asking something in that context earlier, if I understood it correctly.
Yeah. So, when we stop the instance manually and, like stop and then start it, can we start it manually from the web page itself? I mean, going to the S3 bucket, and can we do that from here, or we still have to do it from the command prompt?
No, see, the command prompt, if I just type out logout.
Yeah.
If I press enter, which I'm not going to do, then so I am logged out. That does not mean the computer has shut down. Okay.
Yeah.
But then if you want to manually restart the service, you won't go to the S3 bucket. S3 bucket is not the computer. It is just the storage space. The computer is the instance. The server is the instance.
Yes, sorry, server. Yeah.
Stop or terminate. Terminate means you are completely dismantling the computer. Yeah. Or you can reboot. That's how you will do it. So that clicking on stop and then again, it will take some time to stop, 1 or 2 minutes. And then its status, this IP address will vanish, the public one, not the private one. All this IP addressing thing will be discussed in networking class. They have got a very deep meaning. So, so basically stopping the service, rebooting the service is similar to what I can do from here with the power button. Make sense?
Okay. Yeah.
Now, let us not get into the granular details here, because this is just a preliminary course. Okay. So I'm just trying to, you will have many questions. Hold your horses. It takes some time. There are multiple things. My only objective here is to deploy a website globally so that I can share it on the chat and everybody can open it on your own. Okay. So let's do the succeeding the next steps here. So your answer has been given. If you don't want the services to be restarted manually every time you start the server, you need to use this command. The main command is systemctl, but then with that the additional parameter is enable. and then after that the service name. Here we are dealing with HTTPD service. Okay, so we have till now we have updated our OS operating Red Hat Linux system operating system, and we have installed the required service to render the website. Now there is a specific path and all the folders. I mean, like if you want to deploy anything, if we go to this page here, the welcome page, no, not this, the test page of Red Hat Apache HTTPD, here it is giving us a path where www.html. Right now, no HTML file is deployed. That is the reason why this is just a test page. For our understanding that everything is working fine, Apache is triggering this. But if you want to deploy your own website, you need to do it under this path. And this path is on this computer. Okay, so root var www./html. This is the path. So if I check this now, cd is nothing but change directory. So now I am in this particular path. So how can I check my present location? Present working directory, pwd. So this is my path. I just now changed my directory. Now let me see what is there within the HTML folder. So ll is a long list. These are again commands. So I'm getting total 0. There is nothing. So as long as there should be a file called index.html. Until and unless it is present here, it will not work. Now to make it work, I will have to connect it to the S3 bucket. But for that, I will need additional softwares. Okay, so let me install these additional softwares as well. So DNF, all the updation, yeah, I have done. So let us use DNF, install, while I need something called unzip. And also I need something called Python 3. Let us not get into the details why we need it, because I'm just trying to showcase one simple website deployment. So let's hit enter. I'm sorry, guys, it has actually taken up a little more time than expected. I will kindly request you to be patient so that I can end the session with the demonstration here. So it says complete. That software is installed. Yeah. So, okay. Now what I need, okay, let me go to my home directory. Let me clear the screen. Now I need to download something. Okay, for that, I'm going to use a command called curl. Okay, this is basically a zip file that I'm going to download. It's a lengthy command. So it's actually curl, and then there is a link. I need this software, AWS CLI or Amazon command line interface. Apart from the Linux thing, I also need additional command line interface from Amazon. So this is the link. Okay. But let me explain what is happening here. If I go to this link, see, it is downloading in my system, as you can see here. Okay, if I check my downloads show in folder, so this has downloaded the software in my system to install. So if I do, now this is graphical user interface. Oops. So this is graphical, this is a zipped file. Now I need to extract it and then I need to install it. Okay. But downloading the software in my system will not help. I'm working where? On the remote system. Okay. So that is the reason why from this link, I will download it in my remote system. For that, the command is this. I'm going to use the command called curl. So from this link, I'm going to download it. And I'm giving a name output as AWS CLI version 2. This is version 2. So for that, in Linux, if you need to download a file from a link, you have to use the curl command. Enter. It will do something. And as you can see, it has downloaded 82.8 megabytes. Now, if I do a long listing now, LL, this is the downloaded file. Okay, I'm making it clear again. If I would not have used this command, I need to download from this link, this particular file. and in the remote system. That is the reason why I had to use the curl command. But as I can see, it is in a zip format. So that is why I installed the unzipped software also. So let me unzip it. So AWS CLIV2.zip, let me unzip it. It will do its thing. Done. As soon as you see the prompt here again, that means it is done. So let me pull it up here by typing in clear. So it is, I have downloaded the file, I have unzipped it, but I now need to install it. For that, there is separate command I need to type in. All these commands will be explained in detail later on. Now, if I use this, I got something like this. Okay. So the AWS CLI has been installed. So I will need to use AWS command for connecting from my EC2 instance to the test bucket here. Okay. That is the reason why I am going through installation of all of these softwares one by one. And they have to be done in a particular order. So let me check if the AWS software has been installed properly. So if I fire this command AWS -- version, it is giving me a correct line with the Python version, the Linux version, and this entire thing it is showing properly. And it is also showing that it has been installed on Red Hat Linux version 9. Cool. So till this part, we are doing good. Now I need to sync my S3 service with this EC2 instance. Okay. How can I do that? For that, the command is AWS S3 sync. I need to sync it first. The data stored in the S3 bucket, I will need to sync it here. So I need to give it a link. What is that link? The S3 link I will get from the S3 page. Okay, so there is URL and then there is copy S3 URL. I need the copy S3 URL. I'll do a right click. It will paste the link. So this is my bucket and this is the file in that bucket. Actually, I want to, right now there is a single file. So let me just remove the file. I want the entire bucket. And where do I need to place it? There is a particular folder. If you remember, Apache has already mentioned in their page, welcome page. No, where is the welcome page? Test page. That if you want your own contents to be deployed, then you need to deploy your files under this path. So I have to give this particular path. Right click, where www.html. Cool. Let's press enter. Yeah, this is, let me just have a quick review. AWS S3 sync, the S3 path, and then the path where I'm going to put it, sync it with. Enter. So I'm getting an error, a fatal error, unable to locate credential. Why? I have not authenticated myself. How does the S3 bucket link know that if this request from this EC2 server is valid or not? I have not done any authentication. So I need to access this bucket, and for that I need to validate myself. Okay. So for that, I need another service. If you remember earlier, I had told you we are going to use 3 services. S3, EC2 and IAM. So S3 and EC2 we have done till now, but authentication I have to do through IAM service on AWS. So let me go back here. I will just simply search for IAM or identity or access and access management. Let me open this up. So what am I doing here? I'm going to let it load up. In identity and access management, I need to create something called an access key. Okay. So this is what my IAM dashboard looks like. There will be a completely separate class for IAM. I'm not discussing the details of IAM here. So right now, user, I need to click on users. For which user are you trying to authenticate? I'm trying to authenticate for, if you see, I'm logged in as the admin user. There are other users which have, created here. So I'm interested in the admin user. I'm going to create an access key under security credentials here. Okay. So console sign in, fine, multi-factor. So I need to create an access key here. Okay. This is something which is very private. I'm showing it on the screen here now, but the purpose is here is to give you training. This is something highly confidential. This is not something which is ever shown or shared at all. Okay. So when you create an access key, but I'm going to anyways delete it later on. So it will ask you for the type. Here I'm working with AWS CLI. So I need this type of access key here for the purpose. Okay. I understand and proceed to create a access key. S3 code repo access. I'm using this so that I can access the S3 code repository. Repo stands for repository. So let's create the access key. Now the access key is created. This secret access key will be shown to you only once. Okay. So obviously this is highly confidential. It should be stored very securely and it is not supposed to be shared. Now, so you get only one option to download the CSV file for the access key. Anyways, after the session, I'm going to delete this. So it does not matter for me. But otherwise, if you're not using access key, you should definitely disable or delete an access key. Otherwise, if somebody gets access to this, they can easily hack your system. So right now I will make it visible. I will, let me actually come to that part first. So I've created the access key in the IAM console. So let me go back to the screen here now and update my credentials. How do I do that? Okay. For this, again, you will have to use login here. This is a different kind of login. So let me actually show you. Once you have downloaded the access key, you will have to fire. So after the version thing, there is a separate command called AWS configure. Using this AWS command line, 𝐁𝐚𝐬𝐿 configure. Yeah. It will ask you for the access ID. Okay. So this is what I actually generated now. This is my access ID. The access key and the secret access key. Press enter. Then the secret access key. Copy that as well. Paste it. Press enter. Default region name, I'm keeping all of this none. My only basic purpose is to connect. So now I actually have securely connected. Okay. Now let me again try. Try to do what? Try to sync with the S3 bucket service. So this was the, so this is the URL for the S3 bucket. I have authenticated myself that I'm the genuine user who is trying to access this. And under which path do I want to put in the files which are present in this S3 bucket. Let's press enter and let's see. Let us synchronize it. So as you can see, it has actually downloaded something in this path. Okay, so download from this link 1.html to where www.html.1 the path and then 1.html. Okay, so we have put in our HTML file. Will it work? If I go and refresh this page now, it should work. It did not work. The reason being, it is still coming up with the Linux test page. Your file name should not be 1.html or anything else. It should only be index.html. In any website, the first page that Apache will look, the HTTPD service will look for is going to be the index.html. So let me do one thing. Check my present working directory. It is under root. So I need to go to, so I'll just highlight this here. This is how you see, I only highlighted it. Okay. No Control C, Control V. and I will simply right click. People who are new to Linux, this is how we do it, and press enter. Now, if I check my present working directory, pwd, so I am under the HTML directory now. Fine. So let me do the long listing. So this one.html file was not present earlier. It was present in the, where is it? Under the bucket, S3 bucket. As you can see, but now I have successfully transferred it here. But I need to rename it. For rename, I'm going to use
Kallol, one question here. Initially, you put this HTML file into the S3 bucket and then you imported this onto your EC2 instance, right?
Correct.
My question is, why can't we directly dump it in the EC2 instance, create an EC2 instance and just dump it in there and then start running the HTML? Why should we?
Yes, why should we do that? First of all, one website, a typical website will have hundreds and hundreds of files. Okay. One EC2 instance. Here we have used only 10 gigabytes. We can do the same thing in the EC2 instance. Okay. But then how are you going to transfer the file from your Windows computer to your, from the local computer to your remote computer? You will need some software like FileZilla or WinSCP. So either way, that transfer has to be done. So that means what you are storing in your local system here, that only you are deploying. Now, this is one of the ways. I was actually trying to showcase that S3 can be used for storage. You can store your MP3 files, MP4 files. Entire Netflix works with on the S3 bucket concept. All their movies are actually stored using S3. It is one of the cheapest storage solutions. Okay, so in one go, I'm using multiple services. But yes, you are also saying the correct thing. I could have written the entire code here, but then writing the code is not our task. We are not developers. Okay, we will just use the file given to us by the developers.
Understand.
So let's continue here. So let us see what the developer has written. So I need to rename this. So from one.html, I have to rename it to index.html. Otherwise, Apache HTTP service will not be able to search for it. This is standard practice. So the renaming has done. So if I now do a long listing, I have got index.html. So let's see now what happens. Do we see our web page? So this is a very silly website I have built. So it will just click here. There are multiple buttons here. Button 1 through 5. I click on them and it counts how many times I've clicked. So our website code file, any changes I can make in the S3 bucket. And then, but then this is something which you will learn later on. Instead of doing it like this, we will be using something called Git, because this is just one single HTML page. But in a real-time website, there will be 15 or 20 modules. Each module will be for a mega project, large project. Each module will be worked upon by a team of developers. Just for example, let me show you Amazon.com. If you go to Amazon.com, you have got the sign-in module. You have got the orders module, cart module. Then the products are listed. Do you see? There are so many modules. Each of this click event is actually a module in itself, where there will be multiple developers who have to work. Now just think about it. Globally, every 2 minutes, Google and Amazon and Microsoft, they keep deploying changes. That is how fast they work. If you go to a typical company, one project takes 15 days to 3 months. And that too, if they are not working on agile methodology. So this was the example where, oh, I forgot to actually share this link. Now, if I share this link with you guys, where should I share? On the chat. Check your chat. I've shared this link, be it on a mobile, be it on a whatever you need, device you are using. You should be able to see this same website in a working condition. Just let me know. Kindly test it and let me know.
Hello, sir.
It's working for me.
Thank you for confirming it. So
hello, this is Abdul from Pakistan.
Hi,
I'm extremely thankful to you first that you have cleared many ambiguities in my mind going on with the AWS and S3. I'm an EC2. Many things are going on in my mind, and you have cleared very categorically and very in an easy way. I'm very grateful to you. And
you're most welcome. You're most welcome, Abdul. I'm happy that you were able to learn something.
Yes, I
was
have.
the purpose.
Yes, actually, I have learned because I kept myself understand that S3 is always used to speed up the things. Whenever I asked to my DevOps that why my website is going very slow and my website performance is not as good as I want, that he always used to say that you will have to use S3 to speed up to load the images and the video file.
Exactly. So you are actually trying to upload your videos in the same server in which your website is deployed. You should not work it out like that. So see, that will be a different aspect, Abdul. There can be many different ways. So this was just one very simple way of doing it. Okay. So giving you guys one hands-on demo. There are lots of technologies involved here. There are lots of concepts here. What I have done so fast and so quickly. Just imagine now the same thing. You would need to procure a server. You will need to procure, and that was the whole reason why I gave that cloud concept. I'm like, initially, it took some time, but you guys need to be patient. I will request you to be patient because learning takes time. Learning needs dedication. There is no shortcut. If you guys want to join the course, then be prepared in your mind. This is not a course which you will simply watch the video and if you are thinking that you will be able to learn, that is not the way it works. I will definitely put in my hard work while teaching. I will be showing you, but then you will have to replicate the steps on your own. You will have to do the things physically on your own system. Without hands-on practical training, you will not be able to face interviews because you will not be able to understand. So please have a mindset. It is not easy. It is not easy in the sense that it is not something which you can just learn by watching videos. No, after watching each and every day, please practice. So if I'm giving 50 plus hours of training, 45 to 50 hours of training, my each hour of training will mean 2 to 3 hours of your practice. So instructor-led training, if it is 45 hours, or 50 hours multiplied by 3. So 15 to 3 is 150 plus my 50. 200 hours of training minimum you will have to go through. That will be your self-paced training. So I hope you guys do hard work, because after a period of this 2 to 3 months, then you will be in a position to write your resume and then confidently face a beginner level DevOps interview.
So actually, my question was that you have made us learn that what is EC2 and S3 and the authentications. So let me review myself first. That we have to deploy our websites or everything. So we don't need to use S3 if we are going to use a single page website or a static website.
No, you don't need. No, you don't need.
We also can deploy in the
same website you can do.
As the EC2.
Yeah.
EC2.
Yeah. This was just one of the many thousands and thousands of examples. My objective here was to showcase 3 important AWS functionalities. Did you see the level of security? How I got blocked each and every time? That is what I was trying to showcase. Like without the IAM credential, I would not have been able to connect the EC2 and S3. Even to connect to the EC2, I needed something called a private key file. If you remember, when I used the PuTTY login, right? Before I could log into the console, I had to use that PPK file. So see the levels of security. And later on, you realize concepts like virtual private cloud, subnet, public subnet, private subnet, where we will be further controlling it. Like who can access, who can get in, what data can get in, what data can go out. Access. So things like that.
Sorry. Actually, what is I mean to say that rather than to use S3 for any other purpose, but if I deploy any website directly into the EC2 or Apache in the HTML directory, so it would be much easier that if I change anything in the HTML and upload HTML file into, in a triple,
yes, but then
it will reflect quickly. Rather
reflect quickly,
connect again and again to S3.
But then every time, so here my idea was to showcase, once again I'm repeating, S3 was just a showcasing of that. Not only can it be used to store data, but it can also be used as a code repository. We are actually practically in DevOps world, we are not going to use that. We are going to use Git, wherein, like, just imagine,
yes.
Yeah, we are like, there are 5 developers working on a module. Each of them are working from home, each of over the cloud. Each of them are writing their own bit of software, and then it has to be integrated. So every time you are not going to keep hitting the HTML folder. It is that is a very bad process. Okay, so currently how you can, this was just one single file. That's why I showed it like this. But actually, when we learn Git after a particular stage, which is actually part of the syllabus. Well, I mean, like, it has to be a part of the syllabus. Otherwise, you will not be able to learn. This is part of the course curriculum. Okay, so if you see, this Git thing is there. That all the deployment and all that, initially we will do it manually. Okay, but then later on you will see, if we will write scripts. So the developer will simply make the code change and then push it. That's it. Automatically it will get deployed, the change in your website. Okay, for that it's I mean, like, multiple projects are there. I can't teach it to you in one single class, right? You
of course.
have patience for 2 months.
Actually, Kallol, I just want to interrupt in between.
Yes.
Guys, I have posted a WhatsApp group there. So we'll be sharing the course curriculum and today's recording there. Because obviously you will not be able to understand in one day. But you can watch this recording whenever you have time. You can go through that. So I would request everyone here who has joined this session, who are live up till now, please join this WhatsApp group so that you get a recording. And also you will be in tomorrow's class as well.
I'm going to join 110%. I'm eager to learn version control, everything that sir have already taught.
Yes, all the things that you are going to learn. So obviously we will have to bound the syllabus. There are infinite things to learn. See, there are 3 fields. From my life experience, what I've learned. 3 fields. One is medical science, one is law, and the third one is IT. In these 3 fields, if you are practicing you will forever remain a student. Things keep changing in these 3 fields all the time. Okay, so please prepare a mindset of becoming a student again. Start learning. Learn by learning the concepts and then by doing them practically. Without practical usage of the tools, you will never be able to learn it successfully. So please make sure you work hard. All the best from my end for your endeavor in becoming in the process, in this journey of becoming a DevOps engineer. Having said that, if there is anything else, please feel free to ask. Any other doubt, any other query, please feel free to ask on chat or unmute yourself, and the platform is open. Okay, Emmanuel, request to you, all of you guys, whoever is interested, please kindly join the chat link here.
Can I ask the questions other than the courses? I mean, when this was...
Yes, go ahead.
Before that, Abdul, let me quickly thank Kallol for your time to give us for this demo, and thank you everyone for joining. We can still stay online and ask the questions, but we are just going to stop the recording as of now.
Correct.
Go ahead, please, Abdul. What is your